Hello, in this video I will demonstrate to you how to use DMA multiplexer in practice with combination of timer in PWM mode and external interrupts. Prerequisites. As a hardware I will use Nucleo C031C6 board, which is equipped with STM32C031C6T microcontroller. You can use any other STM32 based board of the STM32 device which is equipped with DMA MUX. To connect the board to the PC, I will use micro USB cable, and as a software, I will use STM32 IDE, and in my version would be 1.11.1, but you can use any other version which is above 1.10.1. As a library, we will use STM32C0 Cube library in version 1.0.0. On the picture you can see as well the location of a green LED, which we will mention in the further part of this exercise. Here on the screen you can see the simplified description of our final application. On the left side we can see the block diagram of the microcontroller and the main components which would be used during this part. So we can see the timer 1, which would work in PWM mode on its channel 1 with period 100 milliseconds. This period will be constant, and it will have the flexible duty cycle, which will be modified by the DMA, and those DMA transfers will be done from the internal SRAM buffer and will be synchronized by the signal coming from DMA MUX, and those signals will be triggered by the events on PC13 line, and this PC13 line will be controlled by the blue button on our board. On the right side of the screen, we can see the final effect on our output channel of timer 1, which is connected to PA5 pin. So we can see the constant period and variable duty cycle. So the time when the LED will be turned on will differ on the different pulse selection, and we should observe it on our green LED. Bit more details about the application. So the timer 1 will generate the signal of 10 Hz on its channel 1, which is connected to PA5, and with flexible duty cycle. This PA5 is used as well to connect green LED called LD4. So it's pretty convenient to observe the final effect without any special equipment. Timer 1 will have assigned DMA channel to transfer its duty cycle, so-called pulse values, from internal SRAM buffer to timer 1 capture compare register 1. And DMA will be synchronized by the external interrupt STI13 signal triggered by the blue button press. Let's start the project using STM32 IDE. I will use this folder as a location of my workspace, and within the workspace I would keep all of the examples related to a DMA MUX, which will follow within this video series. Now I can select this button, Start a new STM32 project. In case you do not have this information center window, you can go to File, New STM32 project. Now we need to specify the part number we would like to use in our example. So in our case it is STM32C031C6T microcontroller, which is located on the selected board. So we'll use a MCU selector tab over here, and I would specify the part number using only C031C6, and then I can see the line with a selected Nucleo board. So this is our microcontroller. I press next. Then I need to specify the project name. So it will be DIM_XTI_DMA MUX. I keep all of the default settings for the project and press just finish. Here is a warning that will switch to the configuration perspective, which is in fact start of STM32Cube MX, which is integrated into STM32Cube IDE. So I just press yes. Okay, we've got our configuration application started. So we can start from the clock configuration review. So by default, the microcontroller selected one, so STM32C0, is clocked by HSI 48 MHz divided by 4. So the system clock is 12 MHz without any PLL, and all of the peripherals are using the same clock. So 12 MHz would be our clock for the timer in this exercise. We'll keep the default settings, so let's come back to the pinout end configuration, and we will start from the timer selection. So we'll go to timers, timer 1, and now we need to specify the mode of this timer. So it will be the only timer we will use within our microcontroller, except the SysTick, which is used for the time base. So we will not use this master-slave configuration, neither trigger source. We'll just specify the clock source as internal one, and we need to configure the channel 1 to PWM mode. So this configuration. No other settings will be done within the mode. Now we can switch to the configuration part of the window and select the parameter settings over here. By default, the prescaler is set to 0 and the counter period is set to 65,000, which is the maximum value for 16-bit register. So we need to have 10 Hz signal at the end. So having 12 MHz on the input, I would propose to divide it first by 12,000. So we need to specify here 11,999 because we are counting from 0. So to the counter we'll put 1 MHz signal. So to have outside 10 Hz, we need to divide it additionally by 100. So again, counting from 0, we need to put here 99. There are no more settings we need to update here at the moment, because pulse value will be modified by the DMA within our application. So those two parameters are enough. Then we need to enable the DMA. So let's switch to the DMA settings. There is no DMA request so far, so just press add, select timer 1 channel 1, and we need to specify the direction, not the default one from peripheral to memory, but memory to peripheral, because we'll transfer the numbers for the pulses from the memory buffer to our compare register of the channel 1. We will specify the mode of the DMA as a circular, we'll keep the memory incrementation, and we will change the data size from half word to word on both sides. Then we need to configure as well the DMA MUX, so we need to enable synchronization, because we would like to have these transfers from memory to timer 1 channel 1 synchronized by the external channel, external interrupt channel, external line, which is PC13 in fact. So we cannot select yet the signal because it is not yet configured. So let's switch to the pinout configuration. And the first thing we need to change is the location of timer 1 channel 1. By default it is PA0, but in our case we would like to use a different location, in fact PA5. And how to make this change? One of the methods is that we can go with the mouse cursor over the selected pin. Then we need to press the Control key on the keyboard and the left button on mouse. And now we can see all of the alternative locations of this function. And then just keeping pressed Control button and left button on mouse, we are just drag and drop this function over the desired pin, in our case PA5, and then release Control and left button on mouse. We just made a remap of this pin to PA5. The next step would be a configuration of PC13 line to external interrupt mode. So we'll go over this line, select left button on mouse, and we'll select the GPIO XT13. Then we need to check this line configuration, whether it is working in interrupt mode on rising edge and whether the interrupt is enabled with an NVIC configuration. So we go to System Core, GPIO, select this PC13. We can see that mode is correct, so it's external interrupt mode in rising edge. So this is what we would like to have. Then we go to NVIC tab and we see that interrupt controller is not enabled. So I will just click enable. Even if this interrupt will be not used in this exercise, it is worth to remember that it is not enabled by default. So let's come back to the timer 1. And now we can finish our configuration of DMA MUX. So we go to this configuration, DMA settings, synchronization signal, and now we can select XT13 as it is right now enabled, and we will use the polarity rising edge. Now the project is ready to be generated, so we just go to Project Manager. Name and location is already selected, so we are ready to generate the project. The easiest way is to use this gear icon, but you can use as well the menu project, generate code, or just save the project by Ctrl S. After I trigger this project generation, I can see another warning that will switch to different perspectives, so set of windows related to the C++ editor. So I'll just select the remember my decision and press yes. So now the complete project would be generated and we can start with the code processing. So as you can see it is finalized. On the screen we can see right now the main.c file. Before we will continue with the code processing, I will just increase the size of the font for the better visibility. So I'll go to Menu Preferences, and then we need to go to General, Editors, Text Editors, Colors and Fonts, Text Font and Edit. Would increase it to 14. And now we can continue. The first thing we need to specify is a buffer which would contain different pulse values. So I would specify it as 32-bit unsigned. I would call it pulses. And let's assume that we'll have 10 components inside. And please remember that the period of our timer is set to 100. So the pulse value should not exceed this 100. So I would use just tens. So 0, 10, 0, sorry. 0, 10, 20, 30, 40, 50, 60, 70, 80, and 90. Please note that I put this definition of the table within this user code begin PV, so private variable section, to be sure that in the next code regeneration, my modification would be untouched. Otherwise, if I would put it somewhere else, outside of any of the user code sections, it will be deleted by the DMAMUX or Cube IDE application. The next point before we will continue with the code processing is verification whether the initialization process is correctly done by our tools. So DMA should be always the first function before any other peripherals initialization which are working with DMA. In our case, timer 1 is working with DMA, so it should be initialized after DMA is initialized. So this is the proper flow at the moment. So the next point would be to start a timer 1 in PWM mode on channel 1 and with usage of DMA. So let's try to find the proper function. We are using HAL libraries, so I will start from HAL prefix. Then we need to specify the peripheral group, so it's timer underscore, and now I can use control space to check the proper function from the list. So it should be something related to PWM and with start and DMA usage. So this function looks pretty okay. So I just double click to select it. We've got 4 arguments. The first one is a handler of the timer we would like to use. There is only one, so I just select the timer one, then the channel, so it's timer underscore. Now if I'm not sure what to put here, I would just press Ctrl space and I can select from the list. So it should be something related to channel. So it's pretty a lot definitions. Yes, channel 1, so this is this one. Then the pointer to the buffer of the data, so in our case it will be just name of the buffer, so pulses, and length is a number of those components within this buffer, so it's 10. In case you would be not sure what to put as an argument, you can go to the function definition or just go with the cursor over this function, and then you can have brief information about the argument lists and possible values which you can put as an argument. This is the end of the coding process. Now we are ready to build the project. So the easiest way is just to press this hammer icon over here. You can use as well build option within this project menu. We see 0 errors, 0 warnings, and on the right side we have as well the information about the memory regions and the memory usage, so the RAM and flash ones. And what we can see here is that we are using close to 15% of the RAM and 37% of flash. Now it is a time to connect our board. So I'm taking a micro USB cable and connecting my discovery board to PC. The board is connected. We are ready to start a debug session. The easiest way is to click this back icon. For the first time it is launching this edit configuration just to check whether everything is okay. We will not modify anything within this debug configuration at the moment, so I'll just press OK. We can see another warning window informing us that we'll switch the perspective, so the set of windows to the debug one. So I would just select the remember my decision and click switch. Now application is ready to be run. So here we can see this play button, so-called resume. If I would press it, my application is start working. I can pause it anytime using this pause button or terminate using this square one. We can have a look as well on the SFR registers. SFR means special function registers. And here we can put, for example, timer 1. And what would be interesting in our case, it would be capture compare register. As you can see, there is error reading value because we need to pause the execution to have the value at the moment stored there. So as you remember, the default configuration of the pulse value was 0, and it should change on each button, blue button press. So at the moment I would press the button once and I would pause execution. So there is no change, so let's do it again. Now I press and I can see that there is a 10 inside this. The reason I couldn't see anything on the first press of the button is that the value is again 0, so I changed 0 to 0, so the effect was not visible. So let's do another test. I will resume the execution. I will press blue button twice this time and I pause it. So now I can see 1E, which is 30 decimal value, and it is in line with our expectations. You can see as well in the meantime on the camera the effect which is visible on the green LED. So we can see the application is properly working. Each blue button press is causing the rising edge on the PC13 line, and this line is used as an external interrupt 13, which is used as a trigger for DMA MUX to generate the synchronization signal, which is transferring one word from the SRAM buffer to our timer 1 capture compare register, and is changing the PWM generation signal at the end. So now we can terminate execution of the code and we can go to the next exercise. More information about DMA MUX you can find in those documents. So dedicated application note AN5224, which is fully dedicated for STM32 implementation of DMA multiplexer. Then you can find some useful information about DMA implementation in STM32C0, and the other lines with an application note 2548. And finally, you can find more details with a dedicated reference manual for STM32C0 family, which is marked RM0490. Thank you for your attention.